so glad you could join me in yet another segment on Wisdom Window. Have you guys been using what we learned beyond the classroom? How are you doing that? I would love for you to tell me in the comment section, or if you want to share it in the next Zoom meeting, that would be super cool. In our last segment, we learned about something called same area in different perimeter. Here we were able to use our knowledge of solving for area by using a formula or by counting on, and then by using our formula for perimeter. And then we were able to distinguish and better understand that we add for perimeter and that we multiply for area. Because for perimeter, we're just finding the outside fence line. That's it, just the sides. And then area, we were finding the entire space within that figure. Pretty amazing. And then we could apply that knowledge to our lives outside of the classroom. So cool how you can use math more than just in the classroom. It can help us with a lot of things in our lives. And now we're going to continue to build on our knowledge of using area by doing something a little different today. So today we're going to be looking at different types of area, and then we're going to work on using our knowledge of fractions to divide those areas into different parts. Isn't that kind of cool? So now we're going to use our prior knowledge of area and our prior knowledge of fractions to help us learn something new. And once again, this is stuff that you can use beyond the classroom. And we can talk about how we can do that later on. So to better understand how we can use area to help us learn about equal area and fractions, I'm going to demonstrate with a piece of paper. And in this piece of paper, I have a grid. I have a width of 2 and a length of 4. And so now this should look pretty familiar. It's a grid. We've been using these for area and perimeter for some time now. But now we're going to be looking at this a little bit differently. Now we're going to look at different ways that we can divide this into equal parts. So let's say I wanted to divide this shape into 2 equal parts. Well, how can I do that? How could I divide this paper into 2 equal parts using the grid shown? Well, there's a couple ways that you can do it, but it's really important to understand that when we divide something into equal parts, that the units inside each of the parts are the same. So, just like how we learned about fractions and how each of the parts need to be equal, we're going to be doing the same thing here and applying that with grids. So, for example, if I wanted to divide this into 2 equal parts, I could fold it in half. And by folding it in half, do I have 4 square units on this side? I do. And do I have 4 square units on this side? I do. And so you see, if we split our figure right down the middle, where this is one part and this is another part, do you see how they both have the same amount of square units? Now that's important in keeping the same area and dividing it equally. Okay? So now, what's another way that we could divide this into 2 different equal parts? I want you to think about that. We can't move any of these boxes anywhere. They have to stay where they're at. Yeah, we could fold it in hamburger style. Okay, now I have a question. How many square units are on this side? 4, exactly. What about this side? 4. Are they equal? They are. So that means we divided it correctly because both of the parts each had 4 square units. So now we're going to be using this information and apply it to different types of area. We're going to divide those different areas into different equal parts. Important to remember that when we divide an area into equal parts, we need to make sure that the amount of square units is equal to each and every part. Okay? All right, so let's go get some more practice in our workbook page. We're going to be on 14-10. So if you would like to pull that up on your computer, or if you want to print it out on a worksheet page, or if you just want to use scratch paper and follow along, that's fantastic. But make sure you're finishing the workbook pages so that way you're getting enough practice to understand and prepare for that test coming up. All right, so let's go work on some workbook pages. Let's go. So now before we get started with our practice book page, I think it would be important to talk about some of the vocabulary that we haven't discussed in a long time. So it's important to remember what a whole and what a fraction is. So a fraction is this right here. And a fraction incorporates the top number, which is a numerator. And a numerator is a specific part being measured. And then the bottom number, which is a denominator, and that is our total number of equal parts. So this is a fraction. And a fraction is basically a part of a whole. So let's say this is our whole. It's just a box, but it's our whole figure. We're looking at something in its entirety. When we have a fraction of something, we're not looking at that whole piece. We're looking at just a part of it. So if we were to split this down the middle and only look at this part, we're looking at one part out of two. And then if we were to divide it multiple different ways, it would have a different fraction. So now today when we work on our workbook page, we might notice that the whole looks different than the wholes that we've been working with when we learned about fractions. And so our wholes might look something like this, like a grid. And although it looks a little different, this entire grid is our whole figure. So that's important to remember when we look at these problems that we will see in just a moment. All right, so remember, a fraction is part of a whole. A numerator is the specific part being measured, and the denominator is the total number of equal parts. All right, let's use this information in our workbook page. So together we're going to be working on numbers 1, 3, and 5. I'm going to model how to do number 1, and then for 3 and 5, we're going to be working on those together. So before I get started, I know that my first step is to read the directions. And the directions say, for 1 through 3, show 2 ways to separate the rectangle into equal parts. Okay, so that means that this is a whole. However, they want us to represent 4 equal parts in 2 different ways, so that's why they provided 2 different figures. So now, if we refer to our example at the beginning of our segment, I had that piece of paper, okay? And remember, we folded it in different ways, but we made sure that the units on both sides were the same as the other. So that's something we're going to be practicing right now. So it says we need to divide into 4 equal parts. Okay. So the first thing I'm going to do is look and see how many boxes I have and then figure out different ways that I can divide this figure equally. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 boxes in length and then 1, 2 in width. If I were to divide this piece into 4 parts, if I drew a line here, 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 and here, would that work? No. Okay, but I do know that that made 4 boxes, and there are 8 on this whole length. And I know that 4 times 2 is 8. So, therefore, if I had 2 boxes in length, I should be able to put a line here, a line here, and a line here, and maybe I'll have 4 equal parts. Let's see. I have 1, 2, 3, and 4. Now I need to make sure I have the same amount of square units in each part. So I have 1, 2, 3, and 4, okay? 1, 2, 3, and 4, 1, 2, 3, and 4, and 1, 2, 3, and 4. Okay, so that's one way you can split it into equal parts. Let's see if there's another way. What could be another way that we can split this into equal parts? So let's see. We know that this is a length of 8 and this is a width of 2. So let's see. Oh, I know. If I can kind of do something like this, but a little different. Maybe if I can see if I can do 4, like 1, 2, 3, and 4, and that be a part, maybe that would work. So I can do that by splitting it down the middle. Okay, and so now I have 8 on this side and 8 on that side. And I know that if I split it down the middle this way, we'd have 4 and 4. So let's see, I have 1, 2, 3, and 4. Draw a line there. All right, so let's see if I have the same amount of square units in each part. 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. And 1, 2, 3, and 4. All right. So that was 2 ways I can separate the rectangle into 4 equal parts. In each rectangle, what is the fraction that shows the area of one of the parts? Now this is important because it's going to be different than what we learned in fractions. Since we're talking about area, you're going to have a whole bunch of little boxes called square units in each of the different parts. But it's important to remember that when we look at the parts of the whole, we're looking at this entire thing right here. So we have 1 part, 2 parts, 3 parts, and 4 parts. And just like here, we have 1 part, 2 parts, 3 parts, and 4 parts. So now if I were to write a fraction that shows the area of one of the parts, I would say, let's do this one. I would say that this is my one specific part. So I have a 1 as my numerator, and then it's divided into 4 equal parts. 1, 2, 3, and 4. So then my fraction would be 1/4. And that would show the area of one of my parts. It's 1/4 of the area of this figure. So let's move on to number 3. And I'm going to have us work together on this one so we can better understand these types of problems. So now we have the same directions. We're going to find 2 ways to separate the rectangle into equal parts. And here we're going to be separating into 6 equal parts. So something that'll help you, I'll just give you a clue for that now, is that when you find the width and the length and you multiply that, you're able to find the total number of squares inside that box. And then you can use your multiplication strategies in order to find out how many parts you can make. So, for example, we have a width of 2. So let's see. Area equals, let's find the length first. We have 1, 2, 3, 4, 5, and 6. A length of 6 and a width of 2. Okay, now 6 times 2 is 12. And so our area of the figure is 12 units. So to divide that into 6 equal parts, if we divide 12 into 2 pieces, we get 6, right? So let's see. Here I have 12. Since we know that this is a length of 6, we know that we can do the same thing up here, except for only once. So we do 1 square unit, 2, 3, 4, 5, and 6. So therefore we have 1, 2, 3, 4, 5, and 6 equal parts with 2 square units per part. And 6 times 2 is 12. And now what's another way that we can do this? I want you to figure that one out. What's another way that we can figure out how to divide this into 6 equal parts? Using your knowledge of multiplication and dividing equally. Remember, each of the equal parts have to have the same amount of square units. Have you got an answer? I'll show you one way that I did it. So let me show you a way that I did it. So I basically just used my knowledge of, like up here, I had 4 equal parts and 4 equal parts here. So now I just used my knowledge of having 2 equal parts here and changed the shape. So for example, like I would have 2 equal parts and then 2 equal parts. I would divide these again because now there are 1, 2, 3, 4, 8 squares. Now I have 4. I divide those into 2 equal parts. So all of these parts still have 2 square units, but it just looks a little different. And so now what would be my fraction for 1 part? Exactly, it would be 1/6 because we made 6 equal parts. This already tells us our denominator, and then we're looking at one of the parts, so 1/6. All right, so now let's move on to number 5. And it says, Maya drew the design shown below. Each square in the design has the same area. Which fraction shows the area of one of the squares? Okay, so now this is going to be a little different because this looks like a grid of these, right? But now it's just having us look at this one specific part. So now that we know that we're looking at one specific part or this shaded area, we know that our numerator is going to be 1. So let's just check to see if we can eliminate any answers. There's a 1 there, 1, 1, and 1. Okay, so all the answers have a numerator of 1. So now we need to figure out which of the denominators best fit this figure. So now since it's having us look at the individual parts, because they're saying that these squares are the equal parts, let's see how many equal parts there are in all. I'm going to do that by labeling. So I have 1, 2, 3, 4, 5, 6, 7, and 8. So how many equal parts are there in this figure? There are 8. So now let's go through, and we need to find something with one specific part with a total of 8 equal parts. So is 1/8 1/4? Nope. Is 1/8 1/3? Nope. Is 1/8 1/6? Nope. 1/8 1/8? Yep. So that is our answer. Just make sure you're showing your work and brainstorming a little bit on how to solve for these problems. So for number 2, you're going to be doing the exact same thing that we did here, except for now you're going to figure out ways to create 3 equal parts. Remember, the best way to do that is to find the width, the length, multiply to find all of the units inside, and then figure out ways to break that equally with the same units inside the figure. And then here it's just going to be a little bit different of a problem, kind of like this one, just a little bit different. So make sure you're looking at those bolded lines when you solve for that problem. Hey, so that was pretty cool, right? We were able to learn how we can incorporate our knowledge of area and fractions, put those two together to better understand how we can divide areas into equal parts. Pretty neat, right? So this can be used in a variety of ways outside the classroom. I would love for you to share different ways that you think you can use it. So this segment's pretty cool because you can use this in a variety of ways. You can use it for different ways to fold a blanket. You can use it to measure a garden and divide it into equal parts depending on how many plants you have. There's an abundance of ways that you can use this information in your life beyond our learning segment. So now before we get going today and before I read you your trivia for today, I thought it would be kind of cool to do another exit ticket. And I'm going to bring you back to my desk and I'm going to show you a problem. And I want you to think for a couple minutes and see if you can find the error that I created. Okay, so now you're going to use that information of fractions and area to see if you can catch my mistake. And if you can catch my mistake, I would love for you to write in the comments. Tell me what I missed or what I did wrong. I look forward to hearing your responses, and now I think it's time to try it out. All right, let's do our exit ticket. All right, and now here is your exit ticket. Just take a moment to look at my work shown, and I wrote my work in pink, and see if you can find the error. I will give you about a minute to look at this. All right, so that was a pretty cool lesson, right? How did you like that exit ticket? Did you find the error? All right, well, remember, if you did, let me know in the comment section because I'd love to see if you caught it. And now I have an answer from your last question for trivia, and then I have a new question for you. So our last question was, what ocean covers the North Pole? And the answer is that the Arctic Ocean covers the North Pole. Pretty cool. Now I have another ocean question. Are you ready? France borders which ocean? Which ocean does France border? Now remember where France is. What ocean does it border? All right, you'll find out the answer in the next segment. And until then, thank you for joining me in yet another segment. We are almost done with this chapter, so make sure you're asking those questions if you're confused. Until then, good to see you, and I'll see you next time.